All right, here we go. 3.11 notes. The main concept here is vertical shifts and vertical shape changes. So that's a little addition here to what's already there. Vertical shifts and vertical shape changes. We want to be a little more descriptive about what type of shape changes are happening here. Now go ahead and flip to the back of the notes, and there's a warm-up there. What I want you to do is pause the video now and complete the warm-up. There are numbered questions 1 through 5. Start with number 1 and do that, and then go through and do all 5 of those. Once you're done, hit play on the video, and we'll discuss the answers. Okay, pause the video now. Okay, so let's look at the answers to that warm-up. So here is what you should have. You can check your chart over here to see if your values match up with mine. We can also check the graph right here to make sure your graphs match up with mine. A couple things to note. F of x, how we got this column. We went to different x values and then found their output. This goes back to evaluating functions, which I believe was 3.2. F of x plus 4, well, that's just the previous column, only plus 4. So I take each number here and add 4 to it to get f of x plus 4. And then f of x minus 3, well, I take my f of x values, my output values, and subtract 3. Okay, so that covers 1, 2, and 3. Now let's talk about 4. What conclusions can we make about the graphs? So looking at these graphs, when we had f of x, that's in black, f of x plus 4, that's in red, and f of x minus 3, the shape of the graph did not change, but the graph was either shifted up or down. So adding or subtracting a value to f of x shifts the graph up or down, but does not change the shape of the graph. Okay, number 5, what would the graph of f of x minus 10 look like? Well, f of x minus 10 would still look the same as these graphs. The shape would not change. However, it would be shifted down so far that some of it would be off the page. It would be way down here. All right, back to the notes. So flip back to the first page here. Okay, first section, vertical shifts. We've got a table of values there. We're going to fill in our x values like this. Now look, we've got a parabola here. We want to pick x values that are going to match up to some of the interesting points in our parabola. And for a parabola, the interesting point here is this turn. So I'm going to kind of center the x values I choose right around 1 here, and I'm going to pick some x values below it and some x values above it. So fill in your chart like that. Now f of x, we get that by, we get f of negative 2, we go to x equals negative 2 and figure out the function's value. So we get f of negative 2 is 4. For f of negative 1, we go here and figure out the function's value, negative 1. For f of 0, we go to an input of 0, figure out the function's value, negative 4. F of 1, similar, negative 5. F of 2, negative 4, negative 1, and 4. This is an important step in the process, and it's going to become more and more important the more we add on to this concept of shifting and changing functions and changing graphs, that we define some points or find some helpful points on our original graph. So make sure that you're doing this step. All right, our next column is f of x plus 3. So all we have to do is take our output values, f of x, and add 3 to them. So we add 3 to each of those output values. 4 becomes 7, negative 1 becomes 2, negative 4 becomes negative 1, etc., etc. Add those values. Now, we want to graph all of these values. We can do that right from here. Each of these points, this was at an output of 4. What's going to happen to it? It's going to go up 3 units to 7. This was in an output of negative 1. What's going to happen? It's going to go up 3 units up to 2. So look right there. If I take all those points and move them up 3 units, I get all of my new points, and I can connect them to get my new graph of f of x plus 3. Okay, in our next column, we have f of x minus 2. So we take our f of x values, and we subtract 2 from each of them. So 4 minus 2 for 2, negative 1 minus 2 to negative 3, and so on. We can do the same thing with graphing over here, where we go to each of our points, and the output here at this point my mouse is on right now is 4. I'm subtracting 2 from the output, so it's going to move down to 2. So all of our points, their output values move down 2 units. And then I connect them to get my graph. And that is the graph of f of x minus 2. Okay, moving on, let's write some rules. What are we observing happening here? So the graph of y equals f of x plus k, if we add k to it, it's shifted in a couple different ways. If k is positive, we go k units up. If k is positive, like right here, yep, like right here, we go k units up. All of our points move 3 units up because we have plus 3. Now, on the other hand, if k is negative, we go k units down. So f of x minus 2, every part of the graph, every point on that graph moves 2 units down, right there. All right, now the next section on your paper is a U-try section. So go ahead and pause the video now and do the U-try, and when you come back, we'll go over the answers. All right, here we go. Let's talk through the answers of the U-try section. Now, notice what I did. I went and I found, I'll make this even full screen for you. I went and I found some points on my original function, right here on the function that was given to me, a point at, oh, I guess this is the one with the graph that's backwards, but I could still find some points on the coordinate grid. And then I took each of those points, and since my function was f of x plus 2, I moved them up 2 units. Moved each point straight up 2 units, and that helped me to draw the new function. Over here, same thing. I found some points on my original function, and then I was doing f of x minus 4. So I took each of the points and I shifted them down 4 units. Down 4 units for each of those points, and that helped me to draw the new function there. All right, let's continue on with the notes then. Back to this. Vertical change, we've got another grid there to fill in. And we've got another parabola, so I'm going to center my x values kind of around this interesting part of the parabola here at x equals 0. So I have that, and then I have 3 x values below it, 3 x values above it. Same way, we're going to go through and find f of x for each of these points. So at -3, we're all the way up at 9. -2 takes us up to 4, so on and so forth, getting these output values for each of the given input values that we've chosen, making sure to put the points on our original graph because they're going to help us. So next column, we want 2 times f of x. So we take our output value from before, our f of x, and we multiply it by 2. So this first one goes to 18. So look over here on the graph. I've already got a blue point ready to go. I'm going to move it up to 18. Oh, there it goes. It doesn't fit on our graph. It went all the way up there off the page. That's okay. Let's move on to the next one. This one, f of x, 2 times f of x becomes 8. So I've got this point here at 4, goes all the way up to 8. And I'm going to continue on in this fashion, taking my f of x values and multiplying them by 2, and then graphing them on for my new function here, for 2f of x. And then we're going to get another one that flies off the page. That's my favorite one. Here it goes. Fun times, fun times. All right, so we connect all of our points there, and that gives us 2f of x. So that's our new graph for 2f of x, or 2 times f of x. Okay, 1/2 times f of x. We're going to follow the exact same process. We take our f of x values and multiply them by 1/2. So 9 times 1/2 gives me 4.5. I take this red point, move it down to 4.5. I take the one that was at 9 before and move it down to 4.5. 4 times 1/2, move that on down to 2. 1 times 1/2, and I'm going to continue on taking my x, or my f of x values, and multiplying them by 1/2 and adding these points onto my graph. All right, so I've got all of these points for 1/2 f of x, or 1/2 times f of x. I connect them, and that is my graph for 1/2 f of x. All right, final column here, negative f of x. Well, this one should be fairly easy because it's just all of the numbers from f of x, only we're going to take the opposite of them. So we've got -9, -4, -1, 0, -1, -4, -9. Same numbers, just negative now. Now this is the coolest animation. I hope you're watching. I like this one a lot. Got our points there. All of them, go just like that. And then we connect our points as best we can to make our graph for negative f of x. All right, now let's explain what happened here. Let's talk through it. So the graph of y equals a times f of x, it's changed in what different ways? Well, if the absolute value of a is more than 1, it's stretched vertically. That's a change. You need to add that in here. Not just stretched, stretched vertically. Stretched vertically if absolute value of a is more than 1. That's the 2 times f of x. Think about taking this black graph here and grabbing these top ends and pulling it up, and then it would look like this. If you pulled them straight up far enough, you'd get to this blue graph. So we're stretching it vertically. Okay? Now, if the absolute value of a is less than 1, the graph is compressed vertically. That's a change. You got to add that in there. Don't just write compressed, write compressed vertically. So that's that graph 1/2 f of x. So think if I took f of x right here, and it continues on out, off the page, and I put my hands on these top 2 corners of f of x, and I pushed it down. I pushed it down this way while keeping the bottom right here. I pushed it down. It would get smashed down, I guess is the best way to describe it, into this red graph. It would be compressed vertically. And then finally, if a is negative, the graph is flipped over the x-axis. Over the x-axis. If a is negative, we flip the graph right over this x-axis. That's a change. You got to add it in there. Flipped over the x-axis, not just flipped over. All right. Oh, yep, that's the graph right there that is flipped over. You should be able to see how we took f of x and just flipped it over the x-axis to get that graph. There's a you try section now. So you try it, pause the video. Once you're done, come back and hit play, and we'll go through the answers together, and you can check your work. Okay, let's check out the answers to that you try section there. All right, here we go. Now this one was a little tricky. My graph here looks pretty bad, but I think you'll get the idea. I'll make it full screen for a second. What you needed to do was to put some points on your original function. I've been stressing this since the beginning. Put some points on your original function. Oh, I'm missing one right there. But you get the idea. I put all these points on my original function. Now here, at an input value of 0 on the original function, the output here is -2. What am I doing with my new function? 3 times f of x. So take that output, -2, multiply by 3, and you're down to -6. Same idea here. Take what is the output on the original function at -2. It's 0. Multiply that by 3, and you get a new output of 0. Here the output is 1. Multiply it by 3, you get a new output of 3. Same thing over here. Define some points on your original function, and then apply the rule to them to find the points on your new function. All right, back to the notes. Back to the notes. Shift and change together. So this is a vertical shift and a vertical change together. So we're going to combine the two things. So x values, choose some key points. This is what I've been saying all along. Choose some interesting points. So let's pick all of those points right there, all of those kind of turning points, or the top of this parabola, the corners. So I'm going to pick one here at -5, an x value of -3, an x value of 0, x value of 2, x value of 3, and an x value of 5. Choose those points, and we're going to write out our f of x, our output values at all of those points. We've got f of -5 is 1, f of -3, -1, f of 0 is 2, and we continue on in this fashion to get all of our output values. Okay, now we have 3f of x minus 2. 3 times f of x minus 2. So we're going to do 3 times this number minus 2. Follow PEMDAS. That means follow your order of operations. Order of operations here, what are we going to do first? We're going to do the 3 times f of x. So when we do 3 times 1, we get 3 minus 2 gives me 1. So now I take my point over there and I move it to 1. Oh, wait, it's already there. Okay, 3 times -1 is -3, minus 2 gives me -5. So I take my point over here, move it down to -5. Continue on in this fashion, getting new points on our curve. 3 times 2 is 6, minus 2 is 4. Take my point, redraw it there. Get my point for 2, going to get the same thing. 3 times 3 is 9, minus 2 gives me that point is going up to 7. And 3 times -1 is -3, minus 2, -5. So I've got all these points. Now I need to obey kind of the connectors from my previous graph. So right here, between this point and this point, in the black points, they're connected with a straight line. So I need to connect these two with a straight line as well. Between these two black points, another straight line, and so on. Right here, this section on the original graph was curved. So I need to make my output graph here curved as well. All right, let's go on. What if we have this point, -2, 7, on our original graph? Where will this point be moved to on this graph? So f of x right there stands for our old y value, whatever y value we started with. So our new y value, we get it by just applying the equation. So our old y value was 7. We plug that in. We follow our order of operations, and we get -21 plus 5 equals -16. So our new coordinates will be -2, -16. And one thing that should make sense if you've been following along adding our points on our graph, when we've been moving our points, we've only been moving up and down. And what coordinate is never going to change when our point is only moving up and down, either stretching up or compressing down or shifting up or shifting down? It's staying on this vertical line up and down, and the x coordinate is never going to change. Look, x coordinate of -2 in the original point, x coordinate of -2 in the new point. Okay, that is the end of the notes. Go ahead and have a good rest of your day.